Hi everyone. In this video, I'll be explaining fractional indices and I'll be working through exercise 3 that you got handed in class to work out for homework. So the basic rule for fractional indices, if we have a base number, a, to the power of b over c, it is going to translate in a root or a surd where the denominator gets to stand outside, the base number stays the same, and the b becomes a power inside the root. So this is the basic law of fractional indices, and this is what you need to apply to work out all of these. So if we take number 1, for example, we've got 25 to the power of a half. That will translate into the square root of 25. There's a 2 there, but we don't write it. A square root is indicating that there is a 2 there, because we have to multiply the same number with itself twice for us to get that answer. And then in the numerator, the 1 at the top, the b goes in there. But since this is a 1, we don't write it either. And we know that the square root of 25 is 5. So the answer for that one is simply 5. Right, the same applies for number 2, where we've got 27 inside the root, the denominator goes outside. Now, because it's a cube root, we have to write the 3 there, but we still don't have to write the 1. That is just the 27 to the power of a 1 is still just 27, so you can just write that. And the cube root of 27 is 3, so our answer there is 3. For number 3, we've got 16 to the power of a quarter. So we're now going to have on the outside a 4, so it's the fourth root of 16 to the power of 1. And 2 times 2 times 2 times 2 gives us 16. So the fourth root of 16 is 2. For this one, students tend to get a little bit scared when they see a fraction raised to a fraction. But a quarter to a half, all you do, the same rules apply. You're going to get a square root where there's a 2 and there's an imaginary 1 there, and you're simply going to get a quarter inside a root, which translates to the square root of 1 over the square root of 4. And the square root of 1 is simply 1 and the square root of 4 is 2. So your answer there is a half. Right, now just want to make some space here. For number 5, we've got 9 to the power of 3 over 2. So we've got 9 inside the root, the 2 goes to the outside, and the 3 in the numerator goes there. So on your calculator, you can work out 9 times 9 times 9, which gives you 729, and then you can take the square root of 729, which gives you 27. So the answer for that one is simply 27. For number 6, we've got 8 raised to the power of 5 over 3. So we've got 8 on the inside. The 3 in the denominator gets to stand outside the root. The 5 gets to go inside with the 8. So if you put that into your calculator, 8 times itself 5 times, you're going to get the answer 32,768. Again, take the cube root of that and your answer will be 32. So 32 times 32 times 32 will give you 32,768. So your answer there is simply 32. All right. Now, if we have a look at number 7, please do not try to do this without any proper working. Give yourself some space. So you've got 16 over 25. Right inside the bracket. This all goes inside a root, the 2 goes on the outside, and the 1 stays on the inside. This translates into exactly the same as root 16 over root 25, which translates the square root of 16 is 4, and the square root of 25 is 5. So your answer is simply 4 over 5. Right, for number 8, Same rule. This is just a little bit tricky because it's not a 1 at the top. So you're going to have 4 over 9 inside your root. This is a root 2, so there's a 2 there, which we don't write. But then it's raised to the power of 3. So the root stays the same. 4 times 4 times 4 gives you 64. And please do not forget to also raise the denominator to the power. So 9 times 9 times 9 gives you 729. And now you take the square root of 64 and you take the square root of 729. And the square root of 64 is 8. And the square root of 729 is 27. So your answer is 8 over 27. Right. For number 9, you've got 27 over 8 raised to 2 over 3. So the 2 gets to stay with that one and it becomes inside a cube root. Right. You do this, you raise the cube root stays the same. In the numerator, 27 squared becomes 729 and 8 squared becomes 64. If you now take the cube root of 729, you get 9 because 9 times 9 times 9 gives you 729, and the cube root of 64 gives you 4. So your answer is 9 over 4. Right, for number 10, this is a multiplication one. So we've got 4 to the power of 5 over 2 times 64 to the power of a third. So what I would suggest is make it as simple as you possibly can. Right, first put the 4 inside a square root, and it's 4 raised to the power of 5 times, and this is the cube root of 64. Use your calculator to work this out. So 4 raised to the power of 5 rooted will give you 32, and 32 and the cube root of 64 is 4. So 32 times 4 gives you 128. The answer for number 10. Right, for number 11, we've got 3 to the power of a third, 3 to the power of a third times 9 to the power of the third, which gives us the cube root of 3 times the cube root of 9. Now, the laws of surds state that you can actually multiply the surd if the root is the same. So we've got a cube root and a cube root, so we can simply do this. 9 times 3 gives us 27. And the cube root of 27 is 3. So our answer there is 3. Right. Next step. Number 12, we've got 4 raised to the power of 2 over 3 divided by 2 to the power of a third. Now there's two ways in which you can do this. You can either decide to change this 4 into a 2 squared and then multiply the powers with one another, or you can decide to change this into a root. Since we are all busy with fractional indices, I'm going to change this one into a root, and therefore we get the cube root of 4 raised to the power of 2 divided by the cube root of 2. Right, now 4 squared is 16, so we've got 16 divided by the the cube root of 2. Now, if I had to rewrite this in a different form, I can simply state that the cube root of 16 divided by the cube root of 2 is exactly the same as the cube root of 16 over 2. So I'm simply taking out the cube root to encompass the whole fraction instead of doing it twice. And then we've got 16 divided by 2 gives you 8, and the cube root of 8 is 2. Right, looks complicated, but if you break it down into smaller parts, it's not that bad. For number 13, this is especially important for the GCSE examinations. They love questions like these where you have to solve x. So this one states 3, the cube root of 20 is equal to 20 to the power of x, and they want you to solve x. The only way you can solve x is if you get the base numbers exactly the same. So we know that 20 to the power of a third is exactly the same as that one, right? And then we've got 20 to the power of x. And because these two, because this 20 and that 20, the base numbers are exactly the same, we can say that x is equal to a third. So x is equal to a third. Right. I'm going to leave that one there and do number 14 here. So we've got 3 to the power of x is in brackets root 3 raised to the power of 5. Same type of rule applies. We've got 3 to the power of x that stays the same, and here we've got 3 to the power of 5 divided by 2 because it's a root and there's an imaginary 2, so the 2 moves down. Right, so x is in fact then 5 over 2. And that is it. I will now do in the next video the second part of exercise 3.